Okay, so here's a pretty standard question to start with. Find the 5/5 roots of 1. Now that could be I or anything, or it could be a fairly hard complex number, but we'll do this one. So what that means is there's a couple of ways you can start it really. Z to the power of 5 equals 1. The reason I like starting with this style of question is because you could be asked to factorise things like that. But if we can solve it, then we can always write it in factored form. So if you've got Z to the power of 5 equals 1, that means Z is equal to the 5th root of 1. Now, you probably think, well, the only answer that this has is 1. But we know that there's going to be 5 of them, and they're going to be spread across the complex plane. The key for this is you write this 1 in mod arg form. So remember, 1 is over here. So that has a modulus of 1 with an argument of 0. So really 1 is equal to cis 0. But it's not only 0, it's every multiple of 2 pi, every time you go around and then back there. So what you do is you go plus 2k pi, where k is an integer. 1, 2, 3, or 4, or even 0, starting at 0. So we get 1 equals cis 2k pi. Okay, so that means z equals to cis 2k pi to the power of a fifth. That's just replacing 1 in mod arg form. Now, by de Moivre's theorem, we can multiply the argument by that number there. So we get cis 2k pi over 5, and where k is equal to 0, 1, 2, 3, 4. There's 5 numbers there. And if you put a 0 into here and a 1 or a 2, it actually lists all the solutions. So we get cis of 0, which is really just 1, cis of 2 pi and 5, cis 4 pi and 5, cis 6 pi and 5, and cis 8 pi and 5. Now that's not a bad answer, but you know this is a 1. That answer and that answer are cool. That answer there, 6 pi and 5 is actually the same as minus 4 pi and 5 the other way. Now, because that's a 4 pi and 5 and that's a minus 4 pi and 5, these are complex conjugates. You actually write it as cis plus or minus 4 pi and 5. And that one are complex conjugates. You can write it as cis plus or minus 2 pi and 5. Okay, so that's how you find the 5/5 roots of 1. If you had to plot them, you'd plot them like this. There's 1, there's 2 pi and 5, there's 4 pi and 5, there's blah, 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 there's blah, blah, blah. So you notice that they're complex conjugates sitting on the unit circle.